In trigonometry, there are special triangles called 30, 60, 90 triangle and 45, 45, 90 triangle. What makes this special is that the sides of a 30, 60, 90 triangle is always a 2, 1, and square root of 3, where 2 is the hypotenuse, 1 is the opposite of 30 degrees, and square root of 3 is the opposite of 60 degrees. In a 45, 45, 90, the sides are 2 for the hypotenuse and 1 for the other two sides. Now let us prove how they come up with these measures. We all know that the measure of all the angles in a triangle is always equal to 180 degrees. In an equilateral triangle, from the word equal, it means that all sides and angles are congruent or equal. This is an equilateral triangle, where all the sides are equal and all the angles are equal, which measures 60 degrees on each angles. Now let's say that all sides are x because they are equal, and when we draw a 30, 60, 90, that means there is a right triangle. So this one, we draw a line to make a right triangle. So as you can see, this is 90 degrees, and the upper side, which is from 60 degrees, and we cut it by half, so that's 30 degrees, which makes this triangle a 30, 60, 90. So if the sides are all x, these two sides here is 1/2 x. We now have to find the measure of this other side. Take note that we are proving that the 30, 60, 90 is a measurement of 2, 1, and square root of 3. So the hypotenuse is x, one side is 1/2 x, and the other side is unknown. In a right triangle, finding the measurement of each side, we use the Pythagorean theorem, which is c squared equals a squared plus b squared, where c is the hypotenuse. Let's substitute. That's x squared equals 1/2 x plus b squared, which is the unknown. We evaluate. That's x squared equals x squared over 4 plus b squared. To eliminate the denominator of 4, we multiply each side by 4. So that's 4x squared equals x squared plus 4b squared. Combine like terms, which is 4x squared and x squared. That makes 3x squared equals 4b squared. To get the value of b, we eliminate the coefficient 4 by dividing both sides by 4. So that's 3x squared over 4 equals b squared. To find again the value of b, find the square root. So square root of 3x squared over 4 is x square root of 3 over 2. And this one is b. So we already have the value of b, which is x squared of 3 over 2. So the sides are the hypotenuse, which is x, or that's 1, and x over 2, or that's 1/2. We just eliminate the variable x, and the other side is square root of 3 over 2. So earlier I have said that the 30, 60, 90 triangle always measure a 2, 1, and square root of 3. So what's the relationship between these measurements and 1, 1/2, and square root of 3 over 2? Well, these are proportionate because when we multiply this by 2, so when we multiply the hypotenuse 1 by 2, that's 2. And the side A, 1/2 times 2, that's 1. And the side B, square root of 3 over 2 times 2, so that's square root of 3. Now that's the reason why, or that is the proof that the measurement of 30, 60, 90 triangle is always the proportion of hypotenuse 2, side A 1, and side B square root of 3. So if we're only given a measurement of one side, for example, the hypotenuse is 6, to get the other two sides, we determine the relationship of 6 and the original measurement of 2. So we divide 6 and 2, so that's 3. So we also multiply the original measurement of side A1 and side B square root of 3 by 3. Now we can get the other two sides with the hypotenuse 6. So when we multiply 1 times 3, so side A is 3, and we multiply square root of 3 by 3, so side B is 3 square root of 3. Now let's proceed to the 45, 45, 90 triangle, or the right isosceles triangle. This is the right triangle and the angles that measures 45 degrees. In a right isosceles triangle, both sides opposite to the hypotenuse is always congruent or equal. That makes the fixed measurement of this special triangle 1 for both sides and square root of 2 for the hypotenuse. Let's prove by using the Pythagorean theorem that c squared equals a squared plus b squared. That's c squared equals 1 squared plus 1 squared. So c squared equals 2, and square root of c and square root of 2. So c is square root of 2. Another example, if both sides are 3, so using the Pythagorean theorem, that c squared equals 3 squared plus 3 squared. C squared equals 9 plus 9. C squared equals square root of 18. So the factors is 9 and 2. 9 is a perfect square, so the value of c is 3 square root of 2. That is still proportionate with the fixed measurement of 1, 1, and square root of 2. So those are the reasons why 30, 60, 90, and 45, 45, 90 triangle are called the special triangles, because they have those fixed measurement which is proportionate to any measure that is given by using the Pythagorean theorem.